Hey, good morning, everyone. My name is Logan. I'm with Flex Machine Tools, and we're here to run a demo for our partners here with Gladwin Machinery. I'm glad you can all make it. I know with COVID-19 going around, it makes things difficult to get in and see a machine. So we're doing what we can to provide you some value here, to be able to see the capabilities, see some demos here ran. We're going to have Mitch Ray with Flow Drill on here as well to walk through some of the details on that. And talk more about the flow drilling capabilities around that demo. I also have Aaron here, who is our programmer and machinist, who's going to be running the machine, and he'll give some additional details on some of the demos and tooling used and some of the capabilities of the machine as well. But I wanted to give you a quick look here at the demos that we are going to be running. Like I said, we're going to be doing a flow drill demo with form tapping. We're going to be doing a demo on what we call our hex block, where we do at shows and whatnot, but that shows the capabilities of the high-speed milling and drilling and the infinite look ahead on the controller. We're going to be looking at two different allied drills that Aaron is going to talk more about and give you some details on and show the capabilities based on maybe what application you're using them on and where they benefit. And then lastly, we're going to be showing a demo on drilling and some slotting in some tube to maybe give you a good idea as to what you can achieve with the machine on some of your applications. But to give you an overview of this machine specifically that we're running this on, it is a G-Series 2004 model with a high output package, which includes a ZF gearbox and a Cat 50 spindle. The motor is an 18 horsepower motor with a ZF gearbox. It gives you the capability to put 22 horsepower to the spindle. Aaron's going to get this demo started here, and once that's running, he'll tell you a little more about the tooling, what kind of programming went into it, and the material as well. That high output package also allows you to get about 400 foot-pounds of torque to the spindle as well. So Aaron's going to talk a little more about the material and what kind of tooling we have on there.
Yeah, so what we got here, we're running, like Logan said, we're running our hex block. The tool that you just watched on the screen there was our OSG Mega Muscle Drill. We ran that guy at 2,900 RPM at 52 inches a minute. So, you know, if you blinked, you probably missed it. So the next tool that we're going to bring up right now is our Kennametal 1/2 inch Harvey 1 end mill. And what we're going to do with that tool is we're going to rough the outside of the block itself. We're going to take a 100th step over. We're going to run at 3,900 RPM, speeding at 39.5 inches per minute. So you can see that tool running now. And Isaac, if you could go ahead and pull up the monitor here, and I'll talk about the program. So I programmed this part in the Mastercam. And one question that came up yesterday, that was a very good question, was the post that was used for this program. Do we have our own post? Do we use a different post? And so what I did was in Mastercam, I just programmed this part with our Haas post. We have some other Haas machines here in the shop, and essentially all we have to do really is change just a couple different codes. So our machine has the capability of having a variation pump pressure with our coolant. So if your normal G code or M code, I'm sorry, for coolant is M8, and how we incorporate that into our programs is we use an M8.1 if we want to use low pressure, and we can go all the way up to M8.4 at high pressure. So all I really have to do is just incorporate those different pressure codes in, and essentially it's the same G&M codes that I would use on my Haas machine. Now, going back to the monitor here, you can see the red line that's kind of shooting out ahead of the highlighted line of code, and that's our infinite look ahead. So what that allows the machine to do is see the moves that are coming up within the program, which allows the tool to follow all of the curves and arcs nice and fluently. So what we're going to do here is we're roughing out the hex, like I mentioned. I pre-drilled the corners on the slots, and I also pre-drilled the center. We're going to put a bore in the center of that hex, and that center hole is just allowing for chip evacuation. But we're going to use this end mill to contour, ramp out the slots, and then we'll do a helix to clear out the center of the bore, and then we'll go back in and run finish passes on everything.
So while this is finishing up, we're going to have a video there on the side that gives you a good overview of the machine, to show you some of the different features, because the camera angles we have currently don't do the machine justice as far as some of the specific features. So here you'll be able to see the T-slot bed. All of the chips actually on there will fall through and are pushed out the end into the chip bin with an auger. This is the setup we have today with the few kert vices there and the pneumatic vice, which I can touch on in a minute as well. There's a tool touch off, the tool calibrator. You may have seen a cord hanging down from the top of the machine. That's just for our GoPro here, so that your machine wouldn't have that. But there's a good look at the auger as well. As you can see, the chips will fall through and the auger will push it. On the Y-axis and Z-axis, it moves using a ball screw, and then on the X-axis, it uses a helical rack and pinion. There you'll see a quick example of our fourth axis capabilities that we have. So if you have a tube that has a lot of holes drilled in it, some slotting, maybe some keyway, that fourth axis is really beneficial. To eliminate the need of any refixturing. It will index your tube to allow you to have one program and not have to refixture, saving a lot of time. Those pneumatic clamps that you saw, and I can show you a better look at that too, allows you to, in the program, have those open and close automatically to eliminate a lot of the time that would be needed to manually loosen all of those vices for a refixture or for the fourth axis to index as well. There's a good look there at the helical rack and pinion and the precision guides along the side of the machine. This is a quick clip here that shows the end of the fourth axis capabilities, which I will touch on a little better here a little longer in the video. It's a great option. It allows you to process in the machine using zones to eliminate the need for the machine to be down. You basically get 100% spindle uptime while the part is running on the other side or in a different zone that you're not working in. You slide that light curtain barrier down, and as long as you're outside of that safety barrier, you can be loading and unloading parts while the machine's still running. So it essentially acts as a built-in pallet changer, if you will. So this is the light curtain I was talking about. As long as you are on the outside of this, you can be doing whatever you need to do on this area of the machine, whether it's refixturing, whether it's setting up fixturing for the next job you have coming up, or just blowing off parts, whatever it is, you're able to do that on the outside of this curtain. If you break this barrier, it will slow down the machine as a warning. If you don't get out of it within that certain period of time, it will stop the machine. And I did want to mention too, on the right side of the video there, you'll see an area for comments. As long as, if you have a YouTube video or a YouTube account or a Google account, go ahead and log in and type your thoughts, your questions, your comments. If you don't have one, you can sign up for one. And like I said in the beginning of the video, we're doing this for our great partners at Gladwin Machinery. They're our exclusive dealer in the Midwest, and we're happy to help them out and be able to provide this awesome opportunity to do this for you guys. It was supposed to be, like I said, a live demo, and things kind of changed on that. But you know, this video allows us to, like I said, show some cycles on some parts, and you know, in addition to this, we're also able to run demos on your parts specifically as well. So maybe these demos that we're showing here today, they don't show exactly what you would like to see, but it gives a good idea. If you want to see it on your parts, let them or us know, and we're happy to film something very similar to this specifically on your parts, so you can get a better idea on ROI and visualize the machine on your specific applications as well. So we're just probably doing a finishing pass here, right, Aaron?
Yep. We're going to do finish passes here, and then once this is done, I'll show you the finish on the part, and then I'll get the next demo set up, ready to go.
Great.
What Isaac's showing here is the simulation video of what this hex part looked like. This is something that, as we program parts, it's a very nice tool to have. Before we post it out and try to run it on a machine, we can run through the simulation. We can check to see if there's going to be any you know, tool crashes, if we miss a feature on the part. So it's really nice to have the simulation in our CAM softwares.
One thing I did want to mention, I know Isaac pulled up that video of the pendulum mode. If you could pull that up again there, Isaac. I know I didn't get the chance to really describe what's going on in that video, but I think if we could get a better look at that again, I can explain that better. So it's really a huge capability of the machine. I mean, a lot of people, immediately the value of the machine is seen with the longer parts that maybe don't fit in your traditional VMC, or you're having to refixture using you know, an older mill or a drill press of some sort. But as you can see in this video, one of our operators is using this machine to, while it's running, you can see him move the light curtain, go into the part, change it out, and then the machine never has to stop moving. It goes from one part to the next, it rapids back and forth. In this video, you know, it's acting like a pendulum, but in reality, you can set that machine up for as many zones as you'd like, as long as it fits within that light curtain barrier, so you're not breaking that barrier so it doesn't slow down. But really, you could have 4, 5, 6, 7 different parts that you'd like to be running if they're all smaller, and you know, be running them while you're working on another area. Let me get there. So here's the finished part that we just ran. So as you can see, the machine, like I said, immediately appeals to those with larger parts, maybe simple hole making, but this just shows the capabilities as well for maybe some more complex parts that requires some additional milling, some high-speed tool paths. And this is where, you know, it could apply to a lot of machining applications. So next, we're going to be running the demo that shows the capabilities of 2 different allied drills. One, and Aaron is going to be talking a little more about this as well, but if you can see down here, these 2 blocks here are what we're going to run those into. So, you know, obviously, like I said, Aaron's going to be showing the different capabilities as he's getting that set up here, and the cycle times are really short. So yeah, these drills, you know, they're a lot smaller, just over, you know, an inch, inch and 11 30 is what they are. But I know firsthand that we've ran up to 3-inch holes, and I'm sure we could run larger as well. We just haven't had the demo that applied to that yet.
Hey, Logan, while I'm getting this set up, do you want to go ahead and grab those inserts?
Yeah.
And I can, you can get a look at them, and I'll talk about them here in just a second. Yeah, so what you're seeing there is the Gen 3 XT Pro. And this drill, so these tools come from Allied Machine and Engineering, and they have reps all over the place. So if you guys are interested in getting more information about Allied tooling, feel free to get a hold of your Gladwin rep, and we can kind of help get the contact information of them on the rep in their area. But this Gen 3 XT Pro drill ranges anywhere from 11 millimeter to 35 millimeter. And these drills are really great for high penetration. And I'm going to get the program started here.
How fast do we drill this one, Aaron?
This drill is going to run at 1137 RPM at 13.6 inches per minute. So these tools are really good for machines and setups that have high rigidity. It's a 2-flute balance. The insert has a balanced cut. And these tools compared to like the Vortex drill that we're going to run next, you run these at a lower RPM and a higher inches per minute. Like I said, it's great for high penetration. I'll take these parts out here and hand one to Logan so you guys can see the part. And the other thing that's nice about these drills is they can hold some pretty tight tolerances. They've been able to hold from anywhere from plus or minus 2 thou. So if you're looking for a high penetration drill, but you still need to, hold your tolerances, this is a great drill to use. Now the next drill that we're going to run is the Vortex IC drill. Logan, if you want to hold up those inserts, and I'll get this part set up. And the nice thing about Allied is they have different styles of drills for different applications. Don't think that one drill is going to be better than the other. There's just certain drills that are meant for certain applications. And a lot of their styles, they have structural grades for each style of drill. If any of you guys are running structural parts, I'm going to get this next program pulled up here.
Yeah, and while he's pulling this up, the reason we're talking about tooling a little bit here is because it can be pretty significant as far as cycle time goes. If you have a high quantity of parts, and cycle time is a concern, which generally it is, but having the right tooling can significantly impact your cycle time. If it's the wrong tooling, it could be double. But the correct tooling, and we have a video that I can have Isaac pull up as well of a combo tool that shows the tool being able to drill and chamfer, eliminating a tool change, and also being able to eliminate the need to go through all of those holes again to get a chamfer on. Yeah, so here is the video I was talking about. It applies a chamfer on that hole while it's drilling. You can eliminate, like I said, an entire tool change and going around that entire part again and hitting all of those holes. In this case, I don't know exactly how much time we saved, but it's pretty significant.
pitch noise. And this kind of goes back to the different grades that they have. The grade that is in the drill right now would be a lot quieter if we were running on, let's say a 4140, 4150 kind of material. As soon as I pull this part out, I'll give it to Logan. The nice thing about these inserts, so it's two different carbide inserts, and it runs at a lower RP or a higher RPM, but a lower feed rate, and that allows the tool to make a nice finish on the part. So this kind of drill works really well in low horsepower applications. It's very good in interrupted cutting. So you can see that we put 2 holes in that part right there. We could easily put, if we wanted to slot the center of that part, we could drill another hole right in the center, and then we could even overlap our holes with this drill. The only thing, if you're doing interrupted cutting with this drill, is you want to slow your feed rate to about 50% to get into the cut. And there's the tool there that you're seeing, the one insert on the outside, and the other indexable insert on the center of the tool there. Now, one other tool that we're not showcasing here today is the TA drill. It's still Allied's #1 drill just because of the versatility of it. So don't take all the information that we're giving you on these Allied drills as us being the experts, because we're not. Like I said before, feel free to get a hold of your Gladwin rep if you're interested into looking at some Allied tooling, and we'll make sure that we get the Allied rep in your area to you, and they'll come into your shop, they'll look at your parts, your applications, and they will help you find the right tooling. So here, Isaac, if you want to get Mitch pulled up, we're going to get the flow drill demo set up.
Yep, and like I said too at the beginning, this is the Cat 50 spindle here. So as you can see, really high rigidity. I know he was mentioning before on that first demo that is for high rigidity applications, and our machine is fully capable of the rigidity for almost all applications. But yeah, Mitch, if you wouldn't mind giving us a quick introduction to yourself. I know I briefly introduced you. Tell us a little more about flow drilling, thermal drilling in general, what kind of capabilities you have using it, industries that are big with flow drilling, and how this may apply to the people watching.
Yeah, sure. Flow drill per se is a great alternative to some of your more common fasteners out there, being if you're using rib nuts or weld nuts in your applications, the flow drill will replace those just using the parent material of the part itself. So what we do with pressure and friction, we introduce the material, goes down through the wall of the material, and we generate up to 3 times the original wall thickness in the length of what we refer to as a bushing or extrusion that we start with. So if you start with say an 1/8" material, you're going to have 3/8 of thread when all said and done. We offer 2 styles of flow drill bits. We have our standard that you see running the demo today, and the standard bit produces what we call a collar on the top side. It's the upflow material is reformed into that, looks like a little washer, if you will, on the top surface. A second option for you guys would be a flat style flow drill bit. What that does is trims all that upflow material away, leaving a spot face finish on the top side. So those are the 2 styles of bits that we offer. We offer any size from a 440 thread size clear up to a 2-inch NPT. Any thread, UNC, UNF, NPT, metric are all available. Just let us know what fits your application, and we can match a bit up to that. Typical lifespan of a flow drill bit is 8,000 to 10,000 cycles, and and it can be used in any malleable material. That's the neat thing. It's not locked into just one type of material. We do stainless steel, we do mild steel, we do copper, we do aluminum, even some brass material is we can use the flow drill process. The neat thing about it is that it eliminates a lot of operations for the customer. We flow drill, and then we use a form tap to create the thread. So in 2 steps, you're done. To utilize the FlexCNC, while we're seeing our customers, a lot of them in the handrail industry and the manifold industry are the 2 big ones that can really take advantage of the FlexCNC machines. And that's due to the length. I mean, they can provide you with any length that you need. And instead of using a standard machining center, having to shuttle the part 2 or 3 times, you got one setup here with the FlexCNC, and you're finished. There's less chance for errors, less setup time, and less process time total. So works very well in that regard.
Yeah, that's a good point, Mitch. And something to keep in mind too for those that are watching. Obviously, the machine is great for long parts, but as you can see on this machine specifically, we've got 4 foot on the Y-axis. So we have 1 square tube set up here, but in reality, we could have 4 or 5 set up all at once.
The cycle times are fairly quick. We normally work within a 3 to 6 second cycle times for most sizes. So it's a very quick process.
Yeah, so for flow drilling, typically it's a paste that's used. You want to touch on that a little bit as well, Mitch?
Yeah, we have our special lubricant that we provide. I mean, it's basically to act as a barrier between the flow drill and the part. What we don't want to have happen is over time, that bit will start collecting some particles of that parent material. And the lubricant is designed to just create that barrier between the actual part and the bit itself to reduce or reduce is the correct word, the buildup of material. We do utilize a tapping oil as well for stainless, especially. For mild steel, you can get away with the coolant and the softer alloys. But for stainless, we do recommend a tapping oil instead of the coolant. It seems to work a little nicer with the stainless steel application, and that can be applied through a spray system as well.
Sure. And another thing to mention too is with flow drilling and form tapping, you don't have a lot of excess material. You don't have a lot of chip cleanup, and I know that's a lot of times a concern. And there isn't any foreign material that is being cut; it's all being formed.
Yeah, there's no chips. We promote it as a chipless process, start to finish. So you flow drill with no chips. You form tap with no chips. The only time that our process will create a chip is if we utilize the flat style flow drill, and that's just trimming off the upflow material on the outer surface. So the chip is always to the outside. So even with that, it's very rare that you would have any debris inside the tubing.
Sure. So what would be the benefit, of form tapping with an oil versus a coolant?
For form taps, it's usually more important to keep that lubricated as opposed to keeping it cool. With a cutting tap, it's designed to keep that tool as cool, like any cutting tool. You want to keep it cool. With the forming operation, since we're compressing that material, it's more important to lubricate it. So oil is typically for the form tap a better choice.
Got it. So you mentioned, obviously using a paste as well. Is that a similar concept, using the paste versus a coolant? It'd be more for protection and lubrication? It
is. It's like I said, it's not designed to cool the bit by any means. We're just trying to create that barrier it provides lubricity to let that bit go through the material easier, but it also creates that barrier between the part and the parent metal and the bit. So we just don't want buildup of the material. onto
Sure.
the tool.
And this is a form tap here for those that maybe are not as familiar.
The cycles are the same. I mean, typically with a forming tap, we can run a little bit quicker cycle time. They're substantially stronger, and then they last longer. There's no cutting edge on it to dull. It just simply compresses the material into the thread formation, and we get our strength that way. So basically, with the whole flow drill process, the flow drill acts more like an annealing operation as it softens the material slightly. And then we work harden it with the form tap operation where we're, again, compressing that material, work hardening it, and that's where the strength comes from the connection.
Sure.
Hey, Logan, if you want to take this over so Tiffany can get a look at that, I'll get the next demo set up.
So here's the part we just ran. You can still see a little bit of that paste there that was sprayed on there that Mitch was referring to. And the small collar as well that is left. And like Mitch was saying, there is another style of drill that you can get that will cut that off to give you a flush surface.
You can kind of see in there, Logan, if they can get any closer, I don't know, but you can kind of see the thread formations and how deep that is compared to the original material. I don't know if you can do an in view there, Logan, or
down into the hole.
You see the difference of that original wall thickness and the amount of thread that you now have simply by using the flow drill operation.
Yeah, so I guess you can kind of see that there. It's kind of hard to focus inside of the tube, but that gives you a good idea.
Mm-hmm.
Isaac, I want to touch a quick point on the program. Can you pull up the screen real quick? So we have a G77 cycle, which is our form drilling cycle, and I'll highlight the line here. G77, and we have our Z negative, which is our final depth, our R plane, which is our return height. Now the next few variables here, the U of negative 150 thou, I 5 point. That's how deep we're going at what feed rate. And as you can see, we have a V that is with our J and a W that's with our K. Mitch, can you kind of explain why the cycle is made up that way and why you have different feed rates for different depths?
Sure. What we want to do, we want to start out relatively slow with the flow drill process, with the operation of the flow drill. We want that material to have a chance to develop some type of heat initially. So our first contact with the part is generally around 3 or 4 inches per minute. And then we're going to gradually increase that as the material allows us to. So as that material starts to soften, we advance the flow drill bit a little quicker as it allows us to. Our intent is to get in and out of the material as quickly as possible. We never want to hesitate once we start a cycle. So when it comes down, we want to get in and out of that material as quickly as possible within reason, starting off slowly, allowing heat to generate, and then advancing as it lets us.
Great, thank you. And just like the Allied tools, we're not the experts. Mitch is here because he's our flow drill expert. So if any of you guys, you can see how easy the program is. If there's any questions, get a hold of your Gladwin guys. They can get you in touch with the flow drill rep or Mitch. But like I said, we're not the experts. Take it from them. We just wanted to showcase how easy it was on the programming side of things. But Mitch, I appreciate it, and we're gonna get this next demo set up.
Very good.
Thanks, Mitch. Yeah, so as Aaron's setting up that next demo there, getting that started, you can see an example of what that finished part is going to look like. We're going to be doing some drilling as well as slotting on square tube, and he'll tell you a little more about that as well. But as he is getting that started, I did want to mention, Aaron mentioned, reaching out to these individuals for tooling suggestions, and something that we're aware of is many don't have the experience in programming as well. You may not have a person on staff that can help program your parts. Maybe you're just starting to get your shop into more advanced equipment. It's mostly manual. We offer a Flex Care package to set you up for success. We will help program your parts, so you don't have to worry about that initially after you buy the machine. We'll also give suggestions on tooling and fixturing. That way there's no questioning as to if you're going to have somebody on staff immediately. And so another thing I did want to mention too is these tubes are maybe 5 feet long, but the machine bed itself, this one specifically is 20 foot on the y-axis, but we can basically make the machine as long as you would require. And something to keep in mind is maybe you have a 10, 15 foot piece, but the idea being if you get a 20 foot machine, 25 foot machine, you could run parts on both sides and then utilize the pendulum processing like we mentioned before. So Aaron's getting this set up. He's going to describe a little more as to what material this is, what kind of tooling we've got, and how he programmed this one as well.
Yeah, so here we're bringing back our OSG Mega Muscle drill. There you can see it plunges through this material nice and easy. This is just 2.5 by 2.5 steel tubing with an 1/8 inch wall. Now after we drill these holes out, we're going to bring our Kinemetal ML back out and contour ramp some slots in the tube. And kind of back to what Logan was saying with the size of the machine here. You can see we're running 4 demos and we're able to change, the changeover is very quick. With the big machine bed, it allows you to set up multiple parts. You can set them up in multiple locations. But we're running 4 demos, back to back to back to back. So if your parts are easily set up to be kind of interchangeable as far as where your work offset's at, it allows you to have multiple programs set up at the same time, so that changeover is nice and quick for you. So here's our Kinemetal ML, and like I said, we're going to contour ramp these slots out, and then we'll bring the chamfer mill out. It's just a 1-inch indexable chamfer mill. It can be used as a spot drill. Now you notice I didn't spot drill any of these holes. I'm using good carbide solid drills. So what I can use that chamfer or spot drill for is after the hole is drilled, I can just come down on top of the hole, give it a nice kiss, leave a good chamfer, and get those burrs off of the holes.
And like I mentioned before, with being able to get your parts in here for a demo to run on this, additionally, we can offer a time study as well. So, maybe you're just in the beginning stages of wondering what kind of ROI you're going to get if this machine was on your floor. Well, we can do that for you. You saw that simulation earlier as well. That's something that we can provide with this time study. But if you want to send over part drawings to your local Gladwin rep, we will be able to give you a full analysis as to what tooling we would suggest, how long that part will take, what kind of changeover, if necessary, would be needed. And then, obviously, after that, we can do the demo as well for you.
So here Logan's got that spot drill tool that I was talking about. It's an indexable carbide insert. There's 2 cutting edges on it. And like I said, it can double as a spot drill. If you want to, pre-spot your holes, you can use it to chamfer your holes after you've already drilled, or here in a second, I'm going to use it to chamfer the top side of the slots as well.
And this goes back to that video we showed earlier on how, tooling suggestion plays a big role. that tool that we showed earlier that was drilling into that flange, that just shows you how you could eliminate this operation, especially if they're all the same size of holes, or several are the same size as well. So you guys saw that finished part. This one's still pretty oily and wet, so I'm gonna let Aaron just keep that one on the bed. But yeah, I mean, so the one other thing I did want to touch on, Isaac, if you can pull up a video of some fourth axis capabilities. Here's the part we ran using our fourth axis. As you can see, this part, obviously is a little unique, but would take a significant amount of time if you had to refixture for each line of these holes. With the fourth axis, it does that automatically within the program. And like I said, maybe this part would be 20 feet long for whatever reason. If you were to utilize pneumatic clamps, they would open and close automatically. Whereas if you were using your standard Kurt vise, refixturing this part would probably be a decent chunk of the cycle time in general. Yeah, so subscribe to our YouTube channel. We're going to be doing more of these as well. This part specifically, we're going to run on the fourth axis. So you can see this actually run and get a better idea as to how that operates and what kind of speed you're looking at. But we're going to actually be doing a tapping arm demo as well here on Friday. And that is going to be at 1 p.m. Eastern Time, noon Central. And that's going to be with Eddie. And OSG is going to be a guest on that as well. So if you're able to make that, please do. Otherwise, it was great being here. Thanks for tuning in. And we hope we can work with you again here soon. Thanks, guys.